Hello, ladies and gentlemen. My name is Lukas Yuku, and today I will be your presenter for the research entitled Development of Canal Gauge Monitoring System based on Computer Vision Technology for Supporting the Irrigation Modernization. Let me open the presentation with introduction about irrigation problems in Indonesia.
Hello, my name is Gali. I'm Lucas' partner in this research. The occurrence of climate change as a result of damage over the last 10 years has caused a decrease and increase in the amount of rainfall from 1% to 4% in different periods. The dry season lasts longer with less and less rainfall. On the other hand, the rainy season lasts a little longer with higher rainfall intensity. Then the current irrigation buildings, according to the Director General of SDA PU 2018, irrigation management has not been optimally seen from the inefficient use of irrigation water. Capacity per capita currently 56.89 meter cubic per second is still far from the ideal. This reason becomes the urgency for the modernization of irrigation in Indonesia, as Pillar 1, improving the reliability and supply of irrigation water. Second, improvement of irrigation facilities and infrastructure. The third, improvement of irrigation management system. Fourth, strengthening irrigation management institution. The fifth, human empowerment of irrigation managers. Several previous studies have developed a water level sensor using ultrasonic sensors, buoy, lasers, etc. However, the sensors have their respective weakness. For example, the ultrasonic sensor has a maximum distance that can be detected by the device. In addition, installation in the field requires having certain difficulties, because it needs to adjust to the dimensions of the channel and the existing field conditions. In this research, we choose camera as a water level sensor because it is affordable and has more advantage than previous sensor. So, in order to improve our irrigation system, the objective of the study was to develop an automatic water level monitoring system using computer vision technology. In contrast to image processing, computer vision aims to obtain information from an image. Meanwhile, image processing only processes images, converting an image into another form. Computer vision is a multidisciplinary field of science which investigates how computers can obtain information from digital image or videos. In computer vision, there is an image segmentation process, which is the process of dividing an image into several segments, usually used to detect objects or boundaries in an image.
For the materials and method, the schematic design consists of infrared camera that is placed at the other side of the canal gauge. The camera takes photo periodically and sends it to the cloud server via Wi-Fi router. The photo is then processed using Python and OpenCV to yield the water level value. The following is the result of the computer vision-based water level monitoring device. The device consists of infrared camera, a mast, panel box, Wi-Fi router, and socket terminal. For the experiment location, it is done at Irrigation Lab, Department of Agriculture and Biosystem Engineering, Gadjah Mada University. The following is an example of a photo data taken by the camera. It is the input image for the water level detection. The first step, we take the image and pass it to the server. And then, select the region of interest by manually specifying each corner of the canal gauge. Next, the canal gauge image is then transformed using affine warp algorithm to remove perspective distortion from the image. The result of warp transformation is then converted into data as shown in graph B. That is by evenly average each row in the results of the warp transformation. Then the intensity variance of the data also need to be calculated, which is shown in graph C. These two data is then plotted and segmented using k-means clustering algorithm. In here, the data is clustered into two groups using k-means clustering. The segmentation result, which is shown in the right graph, already we can see the two groups of data is segmented and the water level value is yielded. Next, we need to confirm is the segmentation success. In this case, we can say it is yes. To calculate the water level, we need to use this formula, where water level equals to canal gauge length minus segmentation point. In here, canal gauge length is 100 centimeters, and segmentation point is located at 62 centimeters. So we get the water level value of 38 centimeters. Then we return the result. But what if in some cases the data is not ideal and cannot be clustered properly? Like this kind of data in here. We can see that the data is not grouped properly, thus it gives us too many segmentation points. In this step, we can say that the segmentation process is unsuccessful. So we should continue using the alternative algorithm, that is adaptive threshold algorithm. Basically, the adaptive threshold works by increasing the contrast in the image and removing the color gradient. The aim is to clarify or further distinguish between submerged and non-submerged canal gauge areas. After that, we apply Gaussian filter in our image so the data become smoother. Next, we segment the image based on intensity difference. The water level is located where the intensity change is the greatest. To calculate the water level, we need to use the same formula where water level equals to the canal gauge length minus segmentation point. In here, canal gauge length is 100 centimeters and segmentation point is located at 59 centimeters. So we get the water level value of 41 centimeters. Then we return the result and end our measurement. The experiment was carried out by measuring water level using the device. To test the device accuracy, the measurement is performed at various water level and 3 different conditions, which is at evening, night, and day. For the result and analysis, above is the series of images taken at lab with varying water level. Note that the red arrow shows the water level measurement by the program. For the data evaluation, we evaluate the 3 conditions, evening, night, and afternoon, using root mean square, error, MAPE, R-square, and the equations is shown. The best result was at night condition, where the color intensity between canal gauge and the water is the most different. However, a reflection by clear water affects the detection by 1 until 3 centimeters lower than actual reading. And we can conclude that development of water level detection for canal gauge using an infrared-based computer vision programs works best at specific condition, because environmental conditions greatly influence the readings of water level. For further improvement in accuracy needs to be conducted for precise measurement and real application in irrigation system. Thank you.